is differentiation. Differentiation is the process of finding the derivative of a function. It measures the rate of change of one variable with respect to another. It helps to find slope, velocity, acceleration, and the other changes in quantities. Notation: if y equals f of x, then the derivative is written as dy over dx or f prime of x. Basic technique of differentiation. 1. Power rule. The derivative of x to the power n is n times x to the power n minus 1. 2. Product rule. The derivative of u times v is u prime v plus u v prime. 3. Quotient rule. The derivative of u v is u prime v minus u v prime over v squared. 4. Chain rule. The derivative of a composite function is the derivative of the outer function times the derivative of the inner function. Other technique. Implicit differentiation. Use it when functions are not in the form y equal f or f of x. Differentiate both sides with respect to x. 6. Trigonometric function. The derivative of sin x is cosine x. The derivative of cosine x is negative sin x. The derivative of tangent x is secant square x.
I will continue explaining for question 2. For part A, we can use this product rule. dy per dx equal to uv prime plus vu prime. Firstly, we need to identify which one is u prime, v and v prime. For v prime and u prime, we need to differentiate first. For u equal to 2x the power of 4. U prime equal to 8x the power of 3. V equal to cos x plus 5. And v prime negative sine x plus 5 times 1. So this is the value for u prime and v prime after we differentiate. After that, we just enter the value into the product rule. Then it will be dy per dx equal to 2x the power of 4 times negative sine x plus 1 times 1 plus cos x plus 5 times 8x the power of 3. Then simplify with negative 2x the power of 4 sine x plus 5 plus 8x the power of 3 cos x plus 5. For part B, we are given y equal to 4x plus 9 divided by tangent x. This is a quotient, so we will use the quotient rule. Firstly, we need to identify which one is u and v prime. dy per dx equal to vu prime minus uv prime divided by v squared. U is 4x plus 9 and v equal to tangent x. To find u prime and v prime, we need to differentiate 4x plus 9 and tangent x. So u equal to 4x plus 9, u prime equal to 4, v equal to tangent x, and lastly v prime, after we differentiate, we get secant square. Then enter the value just now into the quotient rule. So it will be dy per dx equal to tangent x times 4 minus 4x plus 9 secant square divided by tangent x square. So we can simplify with 4 tangent x minus 4x plus 9 times secant square divided by tangent square x.
Hello everyone, in this video I will be explaining how to solve question 3 from our MAT183 Calculus 1 assessment. Okay, First of all, let's begin with the given equation, which is ln y minus 3x to the power of 5 minus e to the power of negative 2x cos y equals to 0. As you can see, this equation is not written in the form y equals to fx, and that is why we must use implicit differentiation. We now differentiate both sides of the equation with respect to x. Remember, we treat y as a function of x, so when differentiating any terms involving y, we must apply the chain rule. Then the first term, which is ln y, the derivative of ln y with respect to x is 1 over y multiplied by dy over dx. This is because the derivative of ln u, where u is the function of x. Then the second term, which is negative 3x to the power of 5. This one is straightforward. The derivative is simply negative 15x to the power of 4. Then the third term, which is negative e to the power of negative 2x cos y. This term is a product of two functions, which is e to the power of negative 2x and cos y. So we apply the product rule, which is d over dx multiplied by e to the power of negative 2x cos y equals to d over dx multiplied by e to the power of negative 2x multiplied by cos y plus e to the power of negative 2x multiply d over dx cos y. Now, let's differentiate each part. First of all, the derivative of e to the power of negative 2x is equal to negative 2e to the power of 2x. Then, the derivative of cos y is negative sin y multiplied by dy over dx. We multiply this because y is a function of x. So again, we apply the chain rule. Now, combine all of it, which simplifies to negative 2e to the power of negative 2x cos y minus 2e to the power of negative 2x sin y multiplied by dy over dx. Now, we move to step 3, which is combine the derivative. Now substitute all the derivative into our equation. Then simplify it. Then we group all the terms with dy over dx. So our final answer will be dy over dx equals to 15x to the power of 4 negative 2e to the power negative 2x cos y over 1 over y plus e to the power of negative 2x sin y.
Hi, my name is Nurhazariza and I'm going to discuss question number 4. So question number 4, s equal 80.99 and s naught equal 81, as x equal x minus x naught, 80.99 minus 81, so you will get negative 0.01. So let's f prime x equal square root of 4x minus 5 over the square root of x. So x 1 over 4 minus 5x negative 1 over 2 to the power negative 1 over 2. 1 over 4x, so if you differentiate, you will get 1 over 4x to the power negative 3 over 4 plus 5 over 2x to the power negative 3 over 2. So there's the formula. F naught minus sx equal f x naught plus f prime x naught multiply sx. So if you just put your numbers in, so you will get square root of 4, 81 minus 5 over square root 81 close bracket plus 1 over 4 multiply 81 to the power negative 3 over 4 plus 5 over 2 multiply 81 to the power negative 3 over 2, and the last one you have to multiply the s, which is negative 0.01. So the last question, so the last answer you will get negative 2.444 because the question asks for 2 to 3 decimal places. So that's all from me. Thank you.